Assalamualaikum friends, my name is Kaisar Aziz and today we are going to discuss about Reynolds experiment. Before going toward Reynolds experiment, we have to learn what is Reynolds number. Reynolds number is basically the ratio of internal forces to viscous forces. Viscous forces mean the viscosity of the fluid. For example, if we consider honey and water, the viscous forces in honey are greater. So from this relationship, we can understand that Reynolds number is directly proportional to V, which is velocity. It means if the velocity of fluid flowing is higher, then its Reynolds number will be more. And if we can see that from this relationship that viscous forces are inversely proportional to Reynolds number, which means if fluid is more viscous, its Reynolds number will be smaller. So we can divide fluids into types of flows: laminar flow and turbulent flow. The laminar flows are which type of flow in which the Reynolds number is less than or equal to 2000. From the relationship, we can see that if Reynolds number is less, the flow will be laminar, and if Reynolds number is higher, the flow will be turbulent. And further, in laminar flow, the velocity of fluid is low. And we can also see from the relationship that if velocity is low, the Reynolds number will be less and ultimately the flow will be laminar. Further, in turbulent flow, the velocity of fluid is high. And also in laminar flow, the motion of the fluid is in regular pattern. It means the fluid will flow in lamination, in layers. But in a turbulent flow, the motion of fluid is irregular. It will move in a random way. And further, in laminar flow, the analysis of the fluid is easy. We can analyze a laminar flow very easy. But in turbulent flow, the analysis is difficult. So now we move toward the Reynolds experiment apparatus. In this apparatus, there is a tank of water and there is one inflow wall, and at the other end there is outflow wall. There is a color dye injector which is installed in the tank for the clear observation of fluid during the flow, which will help us in understanding the type of flow. So there are two piezometers installed at point 1 and point 2. Basically, in this experiment, we can make it in two parts. Part 1 will be one where we start the flow of the fluid. Velocity of the fluid will go on increasing as we keep on opening the inflow wall. And this will be called as ascending flow. The other portion of the experiment will be when we stop closing the inflow wall, then the flow will be decreasing from maximum velocity to minimum velocity. That part will be called as descending flow of fluid. Here we can draw the hydraulic grid line and energy line of the fluid, and in this portion velocity gradient and pressure gradient are shown. Reynolds used energy equation to develop a relationship between head loss and pressure head. We can derive the relation by energy equation, Z1 plus pressure. In this experiment, the pipe is horizontal, so the elevation of pipe will be same everywhere. So we can cancel Z1 and Z2 with each other because they have same elevation. Further, the velocity at part 1 and part 2 will be also same. So these can also be cancelled, and there will be head loss also. So by simplifying this equation, we can get a relationship between pressure head and head loss. This relation helps us in understanding the relationship between pressure head and head loss. Further, we can draw a graph between log of HF and log of HV, which mean velocity and head loss, which will further clear our concept. And this is the graph between log of H of F and log of V. In this graph, we can see that there are two curves, OCA and OCB. The curve OCA is the portion in which the flow of fluid is laminar, and the portion OCB of curve has turbulent flow and this is showing that flow is turbulent. Between C and A there is a transition state, which means the flow is being converted from laminar to turbulent flow. Initially, when we start the inflow wall, the velocity of the fluid is low and which keep on increasing and reaches its maximum velocity. So from O to A portion, the velocity is at the stage where the flow is laminar. But we can see that there is a sudden change in the curve at point A. This point A where is sudden change of curve. This point is called as critical point. And correspondingly the velocity at this point would be called as critical velocity, and the Reynolds number at this point A would be called as critical Reynolds number. From point O, as we move further toward along x-axis, the velocity of fluid is increasing, and from as we move toward origin, the velocity would decrease. We can see in the graph that there is a point below which the flow will always remain the laminar, and that point is C in the graph, and this point is called as the Reynolds number at this point is called as true Reynolds number, below which the flow is always laminar. From this graph or Reynolds experiment, we can get the conclusion that from this diagram we get 2 points. One is lower critical point and other is higher critical point. Further, from this graph we can understand the relationship between I and V, where I is the ratio of head loss over total length. For laminar flow, I is directly proportional to V, and for turbulent flow, I is directly proportional to V raised power n, where n is the slope of the curve. For the O to A portion, the slope is 1, and for A to B, the slope is from 1.75 to 2. So this was the conclusion of Reynolds experiment.